Right. Hello all. My name is Brian, and I'm a math tutor. Been so for many years. I've taught community college, and my job as a tutor is to make math as simple as possible, but still understand it. So today we're going to go through the very first lesson in Algebra 1. We're going to start with commutative stuff, associative stuff, and substitution. So, these things in your general algebra class are called axioms, which means they're the basis for which a lot of math is built. They're like definitions in many ways, but definitions have to make sense. You can't just be like, oh yeah, the cat was purple slash gray. Well, maybe the cat in Alice in Wonderland might be that. But my point being, you can't just go, well, it's a cat, and we're going to make all cats defined as something that is purple and gray. You totally change the definition of cat. You would include, like, clothing that would suddenly be called cat or cat-like. So basically, what I'm trying to get at here is these are definitions, and yet we will still show you why they should work in the ways that they generally do work. Okay, so here goes. So the first thing that you learn about is called commutativity. And the first two operations you talk about when it comes to commutativity is addition and multiplication. So, if you will indulge me, you might remember that when you were a little kid, you learned how to add by counting. So, here is a wonderful chart here. And let's look at this for a minute. This one up here. How many dots are there? Well, you just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think there are 11. And then you continue counting here when you're adding. 12, 13, 14, 15, 16, 17, 18. Okay. So, what is commutativity as far as adding is concerned? Well, commutativity means, if I can show you this again, that you can add these, that you can count these first, then count these, and you'll get the same answer as counting these and then counting these. It's a simple concept. Why do you think it's true? Well, one explanation, which I will give, is that counting these first and then these doesn't change the number of things you're counting. If you count these first, then these, of course you're going to have the same as if you counted these and these, unless, of course, someone ate one of these rocks or somehow got rid of the rock. So, so there you go. That's why commutativity works. Now, there's another thing that they call associativity, and that requires 3 piles of things to count. In this case, we'll just keep calling them rocks. So here you go, 3 piles of rocks. And the question is, like, what is associativity? Associativity means you can count this and this first, and then count that one, or you can count this and this first, and then count that one. It is closely related to commutativity, but you kind of need both in certain circumstances. So, at the beginning, they tell you about both. Okay, so that's addition. What about multiplication? I said multiplication was involved. Now, multiplication is also commutative. You might know this or not know this, but let's just try an example. 4 times 6. What is 4 times 6? It's 24. What is 6 times 4? It is also 24. But how do you convince someone that this happens all the time? Well, if you remember back when you were multiplying at the very beginning, this is what you would see for 3 times 5. Here, don't pay attention to this yet. But yeah, 3 times 5 is just 3 rows of 5 objects. And how did you figure out how many objects there were? You would count them, or add the 3 rows together, or some combination of the two. Excuse me. So, the next question is, why is it commutative? And the answer is, well, if you take this picture and kind of like rotate it this way, doesn't that become 5 times 3? So 3 times 5, 5 times 3, 3 times 5, 5 times 3. And it turns out that by rotating one of these 90 degrees, it basically forms the other. And that's why multiplication, or not, that's not why, sorry. It's one explanation as to why multiplication should be commutative. Okay? Just take your picture and rotate it. Okay, so there's also associativity in multiplication that requires a 3D object to manipulate. But trust me, it works. It just works. Alright, so then we have this thing called substitution. Substitution is actually a really simple concept. If two things are the same and one occurs in like a mathematical sentence, then you can replace it with the other. So, okay, let's talk about non-math first. Let's talk about English phrases. So say we have, go Asians, kidding. Alright, so say we have this. We know that there are two people called the Wang brothers. And we also know that the Wang brothers are John and Drew. So that means that anytime you see the phrase, the Wang brothers, you can substitute that with John and Drew. And anytime you see John and Drew Wang, you can substitute that with the Wang brothers. It's very simple. So the question here is, well, not the question here. Let's do an example. A very simple example. The Wang brothers are celebrating Mother's Day with their mother and grandmother. So the whole sentence was, if you remember, the Wang brothers are celebrating Mother's Day with their mother and grandmother. You can easily replace that with John and Drew are celebrating Mother's Day with their mother and grandmother. Or you can also do that backwards, which is John and Drew are in my car right now, which you could just as easily say the Wang brothers are in my car right now. The whole point is there's two things that are exactly the same, and you can replace one with the other. Case in point for math. We know that 15 is actually 30 divided by 2. Now you might wonder why we would ever need to replace 15 with 30 divided by 2 and make it more complicated, but I'll give you an example in a bit. But it's definitely obvious you don't really want to write to your friend, hi, I have 30 divided by 2 baseball cards, or 30 divided by 2 slices of pizza. You kind of want to simplify. Your friend will get very confused as to why you need to put divided by 2. And they'll probably be like, hey, you can do math. Just divide the 2. Well, here's an example where you would want to make things more complicated. It's an example in mental math, which is just math you do in your head without writing stuff down. But of course, when you're just learning it, you have to write stuff down to make sure you know what the process is. So, here you go. So my initial question is, what is 18 times 15? Now, as you might have guessed from the last quote-unquote slide here, 18 times 15, the 15 can be changed into this. And that's exactly what we do. So here goes. So, what is 18 times 15? Well, it's 18 times 30 divided by 2. Now you might know here that you can do 18 divided by 2 first and then multiply by 30, which makes the problem much easier. 9 times 30 gives you 270. And there you go. So that's a very brief, it's a very brief look at what happens in the very beginning of the very first class of algebra. I might be back with more videos, just going over sort of theory and theoretical questions, because I really think that people should really understand what's going on. And yes, the words are important, like associativity, commutativity, in that case substitution, there's also distribution, but there are reasons why we believe these things to be true, and we assume it's true for all decimals. Or as you will find out, all real numbers is what basically all decimals mean. So, yeah, that's math lesson 1. I had fun. Hope you had fun. Hope you learned something. And I'll be back. Bye.